Welcome back to another tutorial on business analytics in Excel. Today we learn how to summarize data using Excel. We will cover measures of location, dispersion, shape, and association. To make it simple, we are using a data set of 20 graduates and their monthly starting salary. Measure of location tells us where the center of our data is. Think of it as the typical value in your data set. We are going to talk about mean, median, mode, percentile, and quartile. Mean is sum of all salaries divided by number of graduates. In the Excel, we are going to use average function. So we are going to use average, open parenthesis. Again, in Excel, every function that you're using gives you the items as an input that it requires. So for the average function, we need to put the numbers that we want to get an average from. So number 1, number 2, etc. So either you can input the single numbers or you can select the range of the numbers. So I'm going to select from cell B2 all the way to B21, close parenthesis, and that gives the average. For this data, the average is $4,877. This means on average, graduates start around this salary. Next is median. Median is the middle value when salaries are ordered. So in Excel, we use median function. And again, if I select this median, it asks me the numbers that I need to put in the function, and instead of single numbers one by one, I select the whole array of the numbers, B2 to B21. Enter. So the median is 4,815. It means that half of the graduates are earning below this number and half of them are earning above this number. Median is less affected by very high or low salary in our data set. Next measure is mode. Mode is the most frequent salary in the data set. In the Excel, we are going to use mode function. And again, I'm going to give the array of the data, close parenthesis, enter. The mode in our data set is 4,770. And if you look at the data set, we have two of them. If I change this number to any number, which is not the mode, then the function returns an error or not applicable or NA. It means that the data doesn't have the mode. There are two other very popular measures named percentile and quartile. Percentiles tell us the value below which a certain percentage of data falls, and quartiles are a specific version of the percentile where data is divided into 4 equal parts. Let's calculate the percentile, minimum and maximum. So for the minimum, the function is min, mean, open parenthesis, select the array of data. The minimum salary is 4020, maximum salary, the max function, select your array of data, close parenthesis, and this is the maximum salary. 25th percentile mean that 25% of the data is less than this number. Let's calculate it. In the Excel, we are going to use percentile. You can go with the percentile function and then choose the array, comma. Again, Excel function gives you a guideline that what you need to put in the function as an input. So we gave the array B2 to B21, comma, we tell the function which percentile we are targeting. So that would be 0.25 or 25% of the data. If I click enter, that gives me 4,338. That means that 25% of the graduates receive a monthly starting salary less than $4,338. Let's calculate the 50th percentile. I select the array, comma. Now we are talking about 50th percentile, or 0.5. That means that 50% of the graduates has a starting salary less than $4,815. For the 75th percentile, that's equal to percentile, select the array, comma, 0.75. 75% of the graduates has a salary less than $5,267.5. You can also calculate any other number of percentile. Let's go with 40th percentile. You just need to give the percentile when you use the function. Select your array, comma, 0.4. It means that 40% of the graduates have starting salary less than $4,770. So this is the function for percentile and how you interpret it. However, the special occasion or a special form of percentile are 25th percentile, 50th, and 75th. If I divide the data into 4 equal parts, it includes 4 25% data. It means that the largest number in the first part is the 25th percentile. The largest number in the second part is equivalent to the 50th percentile. The largest number in third part is 75th percentile, and the largest number in the fourth part is 100th percentile. So we call this also quartile 1. This is quartile 2, and this is quartile 3, and this is quartile 4, or in another word, maximum. So if you're working with the quartile, you can directly use another function, quartile, that's equivalent to the 25th, 50th, 75th, or 100% percentile. So you select your array, comma. Now look at here. I can select 0, which is basically the 0th percentile or minimum. I can select 1 for the 25th percentile or first quartile. If I put 2, it would be median, 50th percentile. Third quartile equivalent to 75th percentile. If you put 3 and if you put 4, it gives the maximum value or 100% of the data. So I would go with the first quartile. That's equivalent to this number. If I decrease the decimal, this would be quartile 2. So I'm going to select the data, comma 2. This equals to quartile 3. So I give the array, comma 3. You can see that this number are equivalent to these numbers. If I decrease the decimal here. Quartile of the array and comma 4. That would be maximum. So either use the quartile if you are interested in 25th, 50th, and 75th percentile, or you can use the percentile function for any value, any percent of the data you're interested. This is all about location measures. Now we are going to move into dispersion measures. Dispersion measures tells us how spread out the data are. So for example, how this salary measures are spread out. So we have different items for the dispersion measure, including variance, standard deviation, range, interquartile range, and coefficient of variation. Let's start with the range. Range equals to max minus mean. So basically range equals to max minus mean. And we have the maximum, right? We already calculated it. Either you use the number that you already calculated, or directly say maximum of this data minus minimum of this data again. That gives you the range, 1770. Range tells us how data is spread out from the lowest to the highest salary, maximum minus minimum. We have the interquartile range, which equals to quartile 3 minus quartile 1. Basically, I want to know what is the interval between the Q3 and Q1. So that's equal to quartile 3 minus quartile 1. We already calculated it, so we can use numbers here, or you can directly use the quartile function. So interquartile range here is 930. This tells us the middle 50% of the salaries are spread across $930. Interquartile range is very useful in identifying the outliers in the data, and we are going to talk about it when explaining the outlier and the box plot. Next measure is variance. Variance is the average squared difference from the mean. We want to know how far are the data, or how close are the data to the mean. Let's calculate it in the Excel. We go with variance. There are two options: variance of the population when you have all the data about population, or variance of the sample. So either way, if you use variance or var.s, you can get the same answer. So I would choose var.s and then array of the salary, because our data obviously is a sample. Then close the parentheses. It tells us again, variance tells us how far salaries deviate from the mean. Larger variance means more spread. In a similar concept, standard deviation is the square root of variance. If you look at the variance, you can see that it's a very large number. In data analytics, this large number is not favorable. We prefer to downsize the scale of the values so that we can work with them easily. So standard deviation is square root of the variance. You either use the square SQRT function and then you select the variance, or you can use the STDEV. Again, we are going to for the sample, because data is obviously a sample, STDEV.S, and you select your array of the data. So look at the numbers. You can see that 552 compared to 305,034 is very small number, and usually this is much more favorable in analytics study. Standard deviation is in the same unit as the salary. This tells us most salaries are within plus minus $552 of the mean. Next measure is coefficient of variation. Coefficient of variation shows data spread relative to mean. In order to calculate the coefficient of variation, you need to divide standard deviation by the mean. So let's calculate that. We already have the standard deviation divided by the average. A CV of 0.11 means the salaries vary about 11% around the mean. This measure is good for comparing variability across data set without involving the unit. So this measure basically is a unitless measure. It gives a unitless representation of the data spread around the mean. Next set of measure talks about the shape of the data. The first measure is skewness. I'm going to put a picture here. If this is a distribution for the data, we can see that some of the data are skewed to the left, to the right. Some data can be completely normal without any skewness, and some data even can be extremely skewed data. Skewness gives us an understanding about the shape of the data. We can calculate the skewness using the skew function. Select your array and that would be the measure of the skewness. If we have a positive skew, that means that the data is skewed to the right. If the skewness is negative, it means that data is skewed to the left. If skewness is 0, it means that data is symmetric. Here we have a positive skewness. It means that more graduates earn below the mean. If skewness is negative, it means that mean is less than median, is less than mode. If it's positive, mean is more than median, is more than mode. So our skewness is positive. It means that more graduates earn below the mean. So this is the mean, and more graduates are earning less than mean. And few will have a higher salary than mean. That's representing the shape of data clearly. Another measure is the outliers. In order to understand the outliers, we need the concept of box plot, and we need to use the interquartile range measure. So this is actually the concept of box plot in order to identifying the outliers. So we have a range of the data from minimum to maximum. We have quartile 1, quartile 2, which is equivalent to the median, and quartile 3. The idea is to calculate a lower limit and upper limit for the data and consider this interval as a normal range of the data. Any data out of this range would be considered as an outlier. And outliers are the extremely high and extremely low values. In order to calculate lower limit and upper limit, we need Q1 and Q3. Lower limit is equal to Q1 minus 1.5 times of the interquartile range. Upper limit is Q3 plus 1.5 times of the interquartile range. So for the outlier, we need lower limit and upper limit. Lower limit is equal to Q1, we already have it, minus 1.5 times interquartile range, we already calculated it. And upper limit is equal to Q3, or 75th percentile, plus 1.5 times of IQR. Any number, any salary value less than this, and any number more than this is an outlier. There are two ways you can identify the outlier using Excel function. This is completely optional. I can use if function if one of this happen. So we are going to use OR function. It means that either this or this happens. So if this number is less than lower limit, that's where OR function is playing. If this happen, or this number is more than upper limit. So this is my condition. I'm going to close parenthesis. So OR plays a role to make sure if one of this at least happening, then there would be a consequence, and that consequence is putting the outlier word here. So if this value is less than lower limit and more than upper limit, put the outlier in this cell, otherwise put nothing. So this is not outlier, as you can see. In our function, I also need to fix this to number before repeating the function for other cells. So in order to fix the number, I'm going to add $sign before and after the name of the column. I'm fixing the lower limit here, and then for the upper limit as well, $sign before and after F24. So I'm fixing upper limit. Now I can simply repeat this function for the other cells. So you can see that we don't have any outlier because none of this value is below than lower limit or upper than upper limit. Let me change this number to 10,000. 10,000 is definitely much more than $6,900, and you can see that the function identifies it as an outlier. So I also can create a box plot in the Excel. Select your data, insert this icon, gives you histogram and box and whisker. Select box and whisker Excel can give you the vertical box and plot, and you can see that the 10,000 monthly starting salary is considered as an outlier, much above the upper limit. This is the upper limit, 5,790. This is the median. This is the lower limit. I also can change this number to 100, and now you can see that this is also considered as an outlier here. I'm going to stop here. We are going to talk about z-score and the association metrics in the next video.